Alright, this is the last video on chapter 7, and we're going to look at the solutions for the study check in section 7.9. In the last slides we went through these problems, and I'll provide you with the solutions for these problems in this video. Alright, so here you have sodium reacting with chlorine gas, giving you sodium chloride. You start out with 53.2 grams of sodium and 65.8 grams of the Cl2. And you have to find the limiting reactant, the theoretical yield, you're given the actual yield of the sodium chloride, and also find out the percent yield. Another reaction is copper 1 oxide reacting with carbon, giving you copper and carbon monoxide. And you're given 115 grams of the copper 1 oxide and 114.5 grams of the carbon. Again, you have to find the limiting reactant, the theoretical yield, and the actual yield and the percent yield. Okay. All right. So that first one where sodium reacts with chlorine to give you sodium chloride. Okay. So here you have 53.2 grams of sodium. You convert it to moles of sodium using the molar mass of sodium. And then according to the reaction, 2 moles of sodium is giving you 2 moles of sodium chloride. Okay. And so then you convert the moles of sodium into moles of sodium chloride. And once you have the moles of sodium chloride, you multiply by the molar mass of sodium chloride. And it comes out to be 135 grams of the sodium chloride. You do the same steps with the 65.8 grams of chlorine using again the molar mass of Cl2. You convert it into moles of Cl2 and then into moles of sodium chloride using the 1 to 2 mole factor ratio. And then you multiply the moles of sodium chloride by the molar mass of sodium chloride, and so you get 108 grams of sodium chloride. So the limiting reactant is chlorine. It gave you the least amount of product, and that's the theoretical yield. On paper you should get 108 grams of sodium chloride. All right, but you were only able to get 186.4 grams of sodium chloride. So 86.4 grams divided by the 108 grams, all right? So 86.4 divided by 108 times 100 and 80%, all right? So your percent yield is going to be 80%, all right? So again, actual divided by the theory times 100. So 86.4 divided by 108 grams times 100. Okay, and then you get 80%. All right, for the next one where you have the copper one reacting with carbon to give you copper and carbon monoxide. Same process, you take the 115 grams of the copper 1 divided by the molar mass of copper 1 oxide, and then you use the mole ratio of 1 mole of copper 1 oxide to 2 moles of copper, and 1 mole of copper is 63.55 grams of copper. So mole of copper 1 oxide converted to mole of copper, and then multiplied by the molar mass of copper. So 102 grams of copper is the yield. And then you do the same thing with 114.5 grams of carbon divided by the grams of carbon to get moles of carbon, and then multiply it by 2 moles of copper and by the molar mass of copper, and you get 1212 grams of copper. So this is a typo here. This should be 102 grams, not 10.2. Okay, so sorry about that. 102 grams of copper. Okay, so therefore the copper 1 oxide is the limiting reactant. Okay, you're getting 102 grams of copper, That is the theoretical yield. Again, this is a typo, no decimal point here. It's just 102 grams of copper. Okay. So the actual yield is 87.4 grams divided by the 102 grams times 100. So the percent yield is 85.7%. All right, in the other study check with the heat of reaction, you have mercury 2 oxide decomposing to form mercury and oxygen. It's endothermic, the sign of the heat is positive, and the heat absorbed is 182 kilojoules per 2 moles of the mercury 2 oxide. So how many kilojoules are needed to react 25 grams of mercury 2 oxide? So you convert the 25 grams to moles of mercury 2 oxide using the molar mass of mercury 2 oxide. Once you have the moles, then multiply it by the kilojoules and divide it by 2 moles of mercury 2 oxide, and it comes out to be 10.5 kilojoules. The next is how much heat in kilojoules is released when nitrogen and hydrogen react to form 150 grams of ammonia. All right, so you have nitrogen, 3 moles of hydrogen giving you 2 moles of ammonia. This is exothermic because the sign is negative 92.2 kilojoules for every 2 moles of ammonia formed. So take the 150 grams of ammonia, convert it into moles of ammonia, multiply it by the enthalpy value, divide by the 2 moles, and you get negative 406 kilojoules. Okay, the homework for this chapter 7.1 to 7.2 on pages 242 and 243, 7.13 to 7.18 on page 248, 7.19 to 7.26 on page 251, 7.37 to 7.56 on pages 259 and 260, 7.57 to 7.62 on pages 262 and 263, 7.63 to 7.72 on pages 264 and 265, 7.73 to 7.86 on pages 270 and 271, and then 7.87 to 7.100 on pages 274 and 275. All right, and that concludes chapter 7.